Here we go. This is Algebraic Reasoning, Chapter 1.2, Example 2. Miranda and her sister have pooled their money for meals. From the initial amount of money they placed in the envelope, they will spend a certain amount each day on food. The table below shows the balance of money remaining in the envelope after a certain number of days. Miranda and her sister have pooled their money for meals. From the initial amount of money they placed in the envelope, they will spend a certain amount of each day on food. The table shows the balance of money remaining in the envelope after a certain number of days. Alright, so what is the finite differences in the number of days column? Well, it won't take you long to figure out. Well, we're adding 1, adding 1, adding 1, adding 1. Okay, so we're, oh, come on, adding 1. What is the difference? What is the finite differences in the balance thing? So if we take 1 and subtract the previous, so 190 minus 225 is $35. 155 minus the previous one is $35. 120 minus 155 is 35. Every time we subtract it, we find they're all $35. Okay? So the common difference is negative 35. We are adding negative 35, or you can think of it as subtracting 35. That's however you want to say that. That's fine. Does the table represent a linear function? The answer is yes, because x and y both have a constant difference. Alright? What is the balance on day 0? What is the balance on day 0? Well, we got day 1, so we'll go up and find day 0. Well, if we're subtracting 35 to go down, we need to add 35 to go up. So 225 plus 35 is $260. $260. Alright. Then it says use the pattern found in the table to write an equation showing the relationship between D, the number of days, and B, the balance remaining at the end of the day. Okay? So we've got, remember, this is linear, so it's y equals mx plus b, but they want D, the number of days, so that's in my x column, so I'm going to put a D for x. And they want B, the balance remaining at the end of the day. That's my y value, so I'll put a B over here, which I know that's B as well, but you'll survive. So don't forget, that's your rate of change. So 35 divided by the 1, that's your starting point where x is 0. So your equation is B equals 35x, not 35x, 35D for days plus $260. And I made a big mistake here because we're not going up $35, we're going down $35, so it's negative 35. And that would be the equation we wrote for this. Alright? Alright, last question. If the girls continue spending at the same rate, do they have enough money to get through the 8th day? So, okay, so remember we had our equation, I put it here, for the balance equals negative 35 times the number of days plus 260. Okay, that was our equation. So there's two ways of looking at that. You can either look at the chart and you notice on day 7 they only have $15 left. On day 7 they only had $15 left. So if we're taking off 35 every day, they can't get through day 7, let alone day 8. Or you can say, oh, well, let's just plug in 8 for D. So the balance equals negative 35 times 8. That's how many days you're looking for, plus 260. Alright? And 35 times 8, give me a second, let me look that up real quick. Okay, I just did a little math on the side over there, and I found out that negative 35 times 8 is negative 280. So B equals negative 280 plus 260, which that leaves me with negative $20. So the answer is no. They don't have enough to get through the 8th day. No. And you can say because you can say either something like this, because y is negative, or should I say, yeah, y is negative on the 8th day. Or you can say something like this, no, because there isn't $35 left. After the 7th day. Both are reasonable ways of thinking about this. Alright? There we go.